Hello guys, and welcome to our video on data analysis with Python. In this video we'll be doing a general overview on what there is to analyzing your data with Python. Now Python is a programming language, as most of us already have here, and Python is used for several things. It's a very large, should I use something that has several uses, right? You could even use Python for web development, Django, app development, QV, software development, Tkinter, and all that. But in the midst of all this, the most popular and the most ideal use of Python, let me use it that way, is for data analysis / data science. So Python has a lot of features that support and makes data analysis very easy. That is why most people who go into data science, data analysis, they enjoy using Python. Personally, I enjoy using Python for my analysis work. So let's get started. Data analysis with Python. Now, because Python is used for a lot of data analysis, there are libraries built into Python that help you achieve that. Now, these libraries are like things you import into Python. They are built on top of Python, like extra features that can help you do your analysis, not above the normal conventional Python. So the first one and the most popular one is Numpy. Numpy stands for numerical Python. It's a Python library used for working with an array. In Python, we use a list for purpose of array, but it's slow to process. Numpy array is a powerful n-dimensional array object, and it is used in data analysis, linear algebra, Fourier transform, and random number capabilities. It provides an array object much faster than traditional list. I think this is self-explanatory enough, but let me just emphasize on some few things. First of all, Numpy is just like a list, just the same way we have lists in most programming languages. Numpy is a kind of list, but it's faster than the conventional Python list, and it can be n-dimensional. So it's also a very powerful library. Then we have Pandas. Pandas is definitely a library in Python. It's used for relational unlabeled data that provides data structure for manipulating such data and time series. This library is built on top of Numpy library. Now, this is also another library that helps you easily manipulate your data. We're going to be using each of these ones I'm mentioning in the theory section. So Pandas generally provides two data structure for manipulating data. They are series and data frames. Alright. Then matplotlib. Matplotlib is another Python library that helps you to do analysis. Pythonlib is it's more like a graphing software or graphing model. It's easy to use and an amazing visual library in Python. It's very easy to use. It is built on Numpy array and designed to work with border scipy stack and consists of several plots like linear, bar, scatter, histogram, etc. So you could plot different kind of graphs using matplotlib. And the good thing about it is that unlike Excel and those other ones where you have little ability to, although there are a lot of features you can use to manipulate your data, but grassroots manipulation might not be possible. But with this one, you have much more flexibility over your graph. Far more flexibility over your graph. So other powerful libraries for Python analysis include TensorFlow, SciPy, scikit-learn, Keras, PyTorch, etc. I guess in our practical section we're going to be using Numpy, we're going to be using Pandas, we're going to be using matplotlib, and we're also going to be using SciPy. No, not SciPy, scikit-learn. We'll also use scikit-learn. But the rest you can always go and check it out and see how to get started with them. So see you in the practical section. Hello guys, and welcome to the practical session of our data analysis class. I believe we all are already familiar with this environment. This is our Jupyter Notebook environment, and this is the IDE we're using for this course. If you're using whatever IDE, it will still work, but I will recommend Jupyter Notebook because it runs its codes in block. So I've written down some codes here. Just spent some time to write them down so that the video will not be excessively long. So let's just go through them together. So the first thing to do is to import Numpy. So you import your Numpy as np. This is the conventional way to import Numpy. Now Control Shift Enter to enter. So automatically once you see this one here, it means that this block of code has been run. So let us declare our Numpy. array. So how do you declare an array to be a numpy array? First of all, let's type out this array. We have this list. Hope you know this is a list. You just put something like this in Python. You have just created a list. I'm still going to send more videos about general Python. Then this type X. So now I want to find out what type is this for now. So I'm going to find out what type this is. You see, this is giving us a list. If I also find out what type is Y, the type of Y will also be a list. But now I want to make it a numpy array. So what do? I'm going to come here and I'm going to put X NP should be a numpy array and Y NP should be a numpy array. So I do this. If I check what type is XNP, now this is to change it to an array. If I check what type is XNP, I'll see that this is a numpy array, NP array. Now there are so many things you could do together. Let me just run some things. So we could have something like XNP plus X plus YNP. Let's name this okay, this is small x. Let's name this our add. If I want to check what my add is, I'll just come and type add here, and you see that this is the summation of two of those arrays. So you could add arrays together, you could minus arrays together. Let me make this minus. So you have subtracted them. You could even multiply arrays together. Let me use. So we could multiply X NP and let me say 5. So you are multiplying it by 5. So this is like a scalar multiplication and all that. So there are many methods that you could use on this. You could also use a popular one, the shape. If you want to know the shape of the array, okay, let me insert below. But you write np dot shape of this array. It's going to give you the shape of the array and all that. So there are many functionalities in our numpy, but as I said, the main purpose why it's just like a list. But the reason why we use it is because it's way faster than a list, and that's because of some memory stuff that I don't want to bore you with. But just know that numpy arrays are faster than lists. So we have pandas. For our pandas, we'll import pandas as PD. Now, this function here can be used to change a numpy array to a panda series. Is that okay? So if I say this, if I run this, now this name is the name of your numpy array. Unlike numpy that you just put to numpy, where is it now? X is equals to np.array. In this case, also you will name it and you now put pd.series. So in this case, this stuff has changed to a pandas. Now if we check what type ser is, see that pandas.core.series.series. So now this is now a pandas series. This is now a pandas series. Let me see this. Okay, this is not possible here. Alright, so this is the shape. Now this is the head. Now you do this a lot. If you want to see the data set, the pandas data set, you can just run ahead and it will show you the first 5 lines of the data set. Unfortunately, this data set just has it just has how many values? 1, 2, 3, 4. So it's just showing us those 4 values, 1, 2, 3, 4. So that is it. If I make my, let's say I try for y. Let me make this my y now. Come and try. Print out the head. I'll see that this is going to be the head for my y. Now over here is what we call a class. In our series that we're doing, I've not yet taught you guys class. That's why I felt I should just write this down. But I'm going to explain the code to the best of my ability, and I'm still going to send more videos on general Python so that you can understand the reason behind this. But this is a class in Python. Python is an object-oriented program, so you can form classes more like objects. You can create an object, and when you create an object, you create it with methods and functions. You create it with attributes and functions. So this is just a normal. This first line is just a normal init function. It's just a the law just to declare this. Then we say depth train. Now this is where we get into work. So this is training the model. So here I wrote this I defined this class. So it's just basically why I wrote this. I just checked my code and I saw it. Why I actually wrote this was just for me to be able to predict. So this one is more like a predictive this thing. So why am I mentioning this? This one is just using basic. This is just like using only Numpy. They're using core Python to be able to solve it yourself. Now I hope you know that this linear regression has a mathematical calculation. So sometimes some people don't want to stress them. Some people can just decide to solve it using the normal things that Python has. They can combine them together and then form the solution. Like take it step by step. The same way somebody can use his pen and calculate it. Another person can actually use Python to do those calculations one by one. So this is some x dot sum, some s square is equals to self x2 dot sum. All these things are just then the numerator. If you remember when I showed you people how the this thing look like, what's that? The formula looks like. You see that it's the square root of the summation of x square minus the square root of the summation of y square all over the square root of the summation of xy, stuff like that. So those are the calculations that were done here. Then the next is now to predict. So with this you can now predict your stuff. All right, so let's run that model, this model that we just built here. So to define it, I'll just say simple reg this, then simple linear regression is not defined. Okay, I've not yet run this, so let me run this. If I run this, I have to come back and run this. So now I make this simple DBA reg, that is simple beyond data analysis reg. Now, and I say should train my x and y for me. So now that it has trained my y for me, my model for me, I can now come here and do simple reg predict x. So these are the predicted values of x. If I come here, I can put a predicted value of, let me see, of this runs. Okay, I need to put it in a list. So this is the predicted value for 4. So remember I told you that regression is used for prediction. That's one of the important use. So when you run this model, you'll be able to predict what the value will be when we put 4 as our x. So when 4 is x, based on our model, this should be the value of y. So remember that what the x and y now are just these values here. These are the values that we're using for this analysis now. So the next module I want us to talk about is the matplotlib.python. So this one you could use it to do a lot of things. Okay, in this case we just initialize our x and y, import it as plt. So we are plotting a histogram, and so hist is for histogram. Remember I mentioned several plots we could use during the theory section. So if I come here and I run this, so we see the plots we have here. Let me see whether we can plot something else. What if I just make it plot and I put x comma y. Alright, so this is what we have here. Let me make this to be, let me see, 25, and let's make this to be 41. So this is the title of the chart and all that. So you could use it to plot much more complex charts, but this is just what we mean by data visualization. Matplotlib does pyplot as plt. Now I just thought about us redoing the analysis. Remember when we're doing Excel, regression of Excel, there was a data set we used, and in that data set we checked how aptitude test affects performance, right? And this thing was trying to investigate if their aptitude test generally depicted how their staffs will later perform when given the job. And outside that, we now later also did some predictions. So I want to use that same data set to confirm if what Python will give us will be the same thing with what Excel gave us. So let's do that. The first thing is to import Pandas as PD, although we have done that already. So let's do that here again. Then the next thing is to call our data set. Now I've saved that data set on my desktop as what data. I just saved it as data. So df is equals to pd.read csv. I also saved it as a csv file. In Excel, you can save your file as a CSV file. Just as the place where you want to save as, just go down, save as CSV. It's easier for this to work with CSV file than to work with the conventional XLS. So I've defined my variables to be my X to be aptitude score and my Y to be performance. So let me run this. So instead of printing X, let us do df head so that we can see our data set. Df dot head. Remember this to see our data set. So now this is our data set. I hope it's making sense now. Aptitude score and performance. Remember, the head shows you the first four. So this is just to still define this. Okay, we're doing tautology now. I think I've done this already here. So the next thing now is we're going to be using sklearn.linear model from linear regression. Now, in this case, we're not just going to use that long method of defining all those stuff. If you don't know how to define all those stuff, solving them step by step as I did earlier, I'm trying to show you a shorter method you will use to still do your linear regression, and that is using sklearn from linear model. You import it from linear regression. So what do? You come here, you run this. Now it has finished importing. Now we'll now initialize it. Remember I told you if you have a method, there's a class, you have to first of all initialize it. So I think red should be this linear regression. Then fit dot. Now this fit is part of the methods in that part of the functions in this linear regression. So you could still check it off. There are several of them. So this fit is to fit the model. Then this one is to give you the coefficient, and this one is to give you the intercept. So let's go and come here and run this. Okay, let me run this. I think this should be my X and Y instead. Then let me run this again. Okay, this one is a series. Now the difference between series and data frame, sorry I didn't mention it. I think I also missed it. I didn't also mention it in the theory, that's my bad. The difference is that series is a one-dimensional array, while data frame is a multiple dimensional array. Now this particular thing collects multiple dimension array. As I read through the error, I discovered that was the reason why. So this one changes it to a series, while this one leaves it as a data frame. So I don't need this. I said it. I still went ahead to run it. So that was my stop on this. I don't need that. So this has already done the work for us. We're saying that X should be our aptitude score in this data set, and Y should be our performance. So don't worry with time. As you keep doing your Python, you will learn how to interpret your code, your errors, and how to fix them. So this has given us our coefficient 7.9 and our intercept. If you want to see our coefficient, you can also come here and print out our coefficient. Now, does this not look similar with what we did using Excel? If you look at your screen now, you will see our output from Excel, and it looks exactly like that, our intercept in Excel. So that is it. That's just a general overview of Python with data analysis. At least you have seen how it works. You have seen the workflow. I'll send in more materials that you could use to dedicate your time and learn it properly. But the main thing is to catch the workflow and the overview on how it is done. When people hear Python data analysis, some of them just be like, what is even Python? How does it even happen? So now you have seen how it happens, you have seen what is involved, and you can see whether you can tell this line. And believe me, if you tell this line, it will lead you into very other special areas like machine learning, artificial intelligence, data science, deep learning, etc. So thank you for staying true to this point, and bye for now.